Hello, my name is Professor Johnson, and today I will demonstrate quadratic function application type problem. So raffle tickets are sold for a fundraiser with a bike as a grand prize. 200 raffle tickets are purchased when the price is $1. For every 5-cent increase in the raffle ticket price, 4 less raffle tickets are purchased. What should the raffle ticket price be to maximize the money collected in the raffle? Well, first let's think and brainstorm a little bit. If we multiplied the number of tickets sold by the price of each ticket, what would we get? We would get the total money collected. So, for example, it says if you sell 200 tickets and we multiply that by just $1, well, how much total money did you make? $200. So that's the simplest way to look at it. But we know that some things start to change. And the change is from this sentence right here. For every 5-cent increase in the raffle ticket price, 4 less raffle tickets are purchased. So let's imagine that we increase our price. So we started with $1. What if we add 0.05, right? What if we add 5 cents to it? Now, I'll get rid of the dollar symbol because we understand what we're working with. So 1 plus that. So then what would this become? 200 is no longer 200. We really have 200 minus 4. And if we multiply that out, we would get some new value, right? We'd get the total money earned. Now, what if we do this again? What if we increase another 5 cents? So another 5 cents, we add 5 cents to that. And if we did that, we would have 200 minus 4, and we would subtract 4 again. Okay? Because 4 less are purchased every time we do a 5-cent increase. Now, this would really look like 200 minus, 8, or you did it twice, 2 times 4, and then this would be 1 plus, we did this twice, right? 2 times 0.05. So what if we did this 3 times? We would have 200 minus 4 minus 4 minus 4, right? You subtract 4 3 times, and then we would have had to add 5 cents 3 times, but it's easier to represent that as 200 minus 3 times 4 and 1 plus 3 times 0.05. Now you might notice a pattern forming. So let's do this again. So if we do 200 and we do this 4 times, we're subtracting really 16 tickets from 200. And then we're adding to the $1 original raffle ticket 4 times 0.05. because you're doing 4 5-cent increases. So notice we could think of this happening X many times. So let's say X is the number of increases made. So if we do X number of increases, we multiply that by 4. And if we did X number of 5-cent increases, we multiply X times 0.05. And this actually creates some equation. Let's just call it M of X, and this will be total money collected. M for money. Now let's write this a little bit nicer over here. M of x equals, we'll have 200 minus 4x, and then will be multiplied by 1 plus 0.05x. Next, let's FOIL this out. So remember our foiling. Multiply, 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 multiply. So we'd have 200 plus 200 times 0.05x minus 4x times 1 minus 4x times 0.05x. So if we clean that up, this will be 200. 200 times 0.05 gives you 10x minus 4x. And then 4 times 0.05, that'll give you minus 0.2. And then x times x would give you an x squared. So we also would have 10x and 4x come together as a 6x minus 0.2x squared. Now we have created a nice quadratic function for us to work with. So, continuing on, it may be nice to write it as so. Negative 0.2x squared plus 6x plus 200. Now the reason I do this is because now I'm in ax squared plus bx plus c form. So a would be that. A is negative 0.2. B would be 6, and then C is 200. But let's go back to the original question. What we need to do is maximize the money collected. Maximize the money collected. So if we go to the money collected function, m of x, we need to find the max. And where would the max be? Well, the max would be the vertex. And we know how to find the x-coordinate of the vertex. What you do is negative b over 2a. So, negative times 6 and 2 times negative 0.2. And if we put that in our calculator, clean up all those decimals, we actually get 15. Now, remember earlier, x is the number of increases that we've made. So we have made 15 increases of that 5-cent change in price. So let's go back to what we thought about the ticket price. The price really came from 1 plus x times 0.05. Now, if we did 15 increases, right? If we did 15 increases, what's the new price of the raffle ticket? That would end up being 1.75. So, this would be the raffle ticket price for maximizing money collected. So that would be the ideal raffle ticket price. Now, if we wanted to know how much money that would really be, well, we could use m of x, and you could put m of 15 in for x, and that would multiply through as so, and we would collect a total of $245. Now, another way to do that is go back to what we did before. We had 200 minus 4 times x times 1 plus 0.05 times x. Now, instead of x, if we replace that x with 15, we replace it with 15, well, as magic has it, we would end up with $245 again. Thank you for watching my video.